Welcome to the channel R. And here you are seeing a question for KCET NEET. In the following figure, right, potential difference across the resistor R2 is. We are having the picture here, and in this picture we are about to find the potential difference across the resistance R2, which is positioned here in the middle. Okay, I am calling the 2 points across this resistor as A and B. And to find this potential difference across R2, I am having two methods. So today I am going to tell you in detail about those two methods. First of all, what you know is about Kirchhoff loop rule. In this rule, we consider this as one loop and this as the second loop. In the first loop, due to this battery, a current I1 is flowing in this direction, and in the second loop, due to this battery, a current I2 is flowing in this direction. The two currents will meet at point A, and combined current flowing in this direction in the middle branch as I1 plus I2. So now I consider this loop, the left loop, in a clockwise direction, first loop, and the second loop I consider in counterclockwise direction. Now uh, I apply the rule with reference to this point, and since the current is in the direction as I considered, right, so for that I should consider this current in this loop as positive. So then I should consider the product of current and resistance together. So that means it is plus 4 times I1, right? And in this branch there is no resistor. So in the middle one, the current is I1 plus I2 and the resistance is 2. So this is also plus 2 into I1 plus I2, right? So there is no resistor in the bottom branch. So that is the end. So that must be is equals the EMF. The lower end of the battery is negative and the upper end is positive. So it is to lower to higher level. So for that I should consider the potential as plus 28 is the EMF, right? So when I solve this one, probably I may get it is 6I1, right? Plus 2I2, which is equals 28. Otherwise, when I divide all these by 2, right? So when I divide it by 2, I may get 3I1 plus I2, which is equals 14. This is my first result for the first loop. And doing the same for the second loop. Okay, so now I do the same for the second loop, and this point is my reference point, and I go like this as a loop. Okay, so since the current is also in the direction of consideration, this current I2 is also becomes a plus. Okay, so then what I have to write is plus 1 into I2 is simply I2, that is uh, all about the first branch, and here we are having no resistor, and in the middle it is again plus 2 times I1 plus I2, right? So which is equal to, because no more resistors are here in the bottom, so it's equal to EMF. Again it is from lower to higher. This is plus 7, right? So when I solve this one, it becomes 2 times I1 plus 3 times I2, which is equal 7, and I call this equation 2. So now I have to solve equations 1 and 2, which may yield me to get the values of I1 and I2. Okay, so solving I1 and I2 now. So solving for I1 and I2, I1 and I2 in equations 1 and 2, in equations 1 and 2. So when I do that, I simply do one thing. I keep the first equation multiplied by 3. Okay, so equation 1 should be multiplied by 3. So which means what I get, it is 9 times I1 plus 3I2, which is equals, how much I get? I get 42. And when I write the second equation as it is, I do nothing, equation 2 multiplied by 1. So which remains as it is, that is 2 times I1 plus 3 times I2, which is equals to 7. So when I subtract them, I have to change their sign like this, So when I do that, it becomes 7 times I1 plus 0. So because these two terms get cancelled, and this is equal to 35, right? So here what I get, I1 is equal to, it is 35 divided by 7. So which means I1 is equals to 5 amps. So this is what I got about I1. So I got I1 is equals 5 amps. So once I know I1, so now I can easily get I2 by using second or first or whatever the equation I may treat. So now in one, now in equation say 2, it is better for me now. So it is 2 times 5, right, plus 3 times I2, which is equals to 7. Otherwise, I may take it 10 plus 3, I2 is equals to 7. Further doing this, it is I 3 I2 is equal 7 minus 10, which is minus 3, right? So further, what I can do is I simply treat like this, So it is I2 is equal to minus 3 divided by 3. It becomes I2 is equals to minus 1 amps. The significance of this negative sign here in this value says that the current what we treated in this direction is in actual it is opposite. Okay, that is the meaning of the negative what we got, right? So now in the middle branch the total current is I1 plus I2, right? For that what I have to do is in the middle branch, right, in the middle branch the potential difference is, so potential difference across all two is equal to the potential difference between A and B, so which is equals the current is I1 plus I2, right? Current is I1 plus I2, it is multiplied by resistance R2. So which is equals, what I can do is I1 is 5 amps, so what I got here, right? So I1 is 5 amps, yeah, and I2 is a minus 1, right? So minus 1 should be written here along with the sign, and it is multiplied by the value of resistance, which is 2 ohm. When I do this, this becomes 4 into 2, definitely it is 8 volt, right? So the potential difference across the ends A and B, here is A and here is B. The answer comes 8 volt. That is the potential difference between the two terminals, and the answer is 8 volt, right? So answer is 8 volt. Don't forget it. And now I have to show you the second method, okay, where I should get the same value of voltage. Uh, Now I'm applying the second method, that is superposition theorem. Superposition theorem. In that, what I do is a simple thing. Okay, so short the batteries one by one. Short the batteries in batteries in steps. In steps. So first I short. Okay, so I short uh, 28 volt battery. So what I get in the picture, right? So here is the picture what you are seeing. I simply short this one. I just remove this 28 volt battery and simply make short circuit. So here is 4 and here is 2. Here is 1 and this is 7 volt, right? So that is what I am going to do now. Here, uh, this is 4 volt and I removed the battery, right? So here is the resistance. How much the value of resistance? 4 ohm. And here is the middle one. Middle is 2 ohm resistor, and here I am having a 1 volt resistor along with a battery of 7 volt, right? That is 1 ohm and this is 7 volt, and these things are connected together, right? This is how I have to make, and here should be that battery, but it is now what, short circuited. Okay, so now I have to treat this as a single network, and here when I solve, the effect of these two is for this branch, right? So these two branch resistors are 4 into 2 divided by 4 plus 2. So definitely it is 4 into 2 divided by 6. It is 3 into 2. Definitely it is 4 by 3 ohm. So these two are parallel, that is 4 by 3 ohm. And here is one more resistor, that is 1 ohm, that is in series, right? So therefore what I have to do, I have to add that one in series. 4 by 3 plus 1, definitely it is 7 divided by 3, right? 7 divided by 3 ohm. This will be the resistance of the whole network. So now the current in the network, the main current in the network should be considered, and that current is I. So that is what I have to find now. The main current main current I is equal to the EMF is 7 and total resistance is 7 divided by 3. So it is 3 amps. So this is the main current that is flowing here, right? So it is 3 amps. See one thing here, when the current comes to this point, it will split into two parts. One thing you have to observe, if we treat this as R and this as R by 2, because it is 4 ohm and it is 2 ohm, right? Then the current which is going here is 1 by 3 of the main current, and here whatever the current that goes, that will be 2 by 3 of the main current. Okay, so now the current here, what it is passing, that is something like this. I by 3 into I mean 1 by 3 into I, it is 1 amps. 1 amps is flowing here, but I'm not interested about this one. I'm interested about the middle one, because the point A and B is existing here, right? So 3 in the 3 amps, 1 amp current is going here. So 2 by 3 means right, 2 by 3 into 3 amps. So this is equal to 2 amps. So 2 amps current is flowing in this direction. Definitely the current which is here is 2 amps, which is in downward direction, right? Downward direction. Yeah, now I would do what? Now consider the second point, that is short uh, 7 volt battery. So when I make this 7 volt battery shorted and just put this battery again, right? So even battery, that is 28 volt battery, should be replaced now. So now considering that one, here is 4 ohm and here will be 28 volt battery, and in the middle we are having the 2 ohm resistor, and here is the 1 ohm, and you can see that the 7 volt of battery is now shorted, right? So it is 4 ohm, it is 2 ohm, it is 1 ohm as it is, and here is again our 28 volt battery, right? So now I made what? I short circuited the 7 volt battery, right? So this is how we deal with the circuits in superposition theorem. So now what I have to do is the sum of the effective resistance of this branch is 2 into 1 divided by 2 plus 1, which is 3. So which will be simply 2 divided by 3 ohm here, and it becomes a series with this 4 ohm. So that means 4 plus 2 divided by 3, this will be 14 divided by 3 ohm. This is the effective resistance of this whole network. Now, how much current that is flowing should be found. The main current which is flowing here is again I treat it as I. How to find I now? So, to get I main current, right? So, main current is equal to, it is 28 volt divided by the effective resistance of the whole network is 14 divided by 3, and this is 2, right? So, this is equal to, right? This is equal to, it is 2 into 3, which is 6 amps. This much current is flowing here, which is 6 amps. And now as soon as the 6 amps current comes here, again it splits into the different branch currents, and if we treat this as the resistance R and this as resistance R by 2, again a current of 1 by 3 amps that flows, 1 by 3 I flows here, and 2 divided by 3 current flows here, right? 2 divided by 3 of the main current flows here. But I am interested about this branch because the point A is here and B is here. So how much current I should treat now? So I should treat a current it is a 1 by 3 times I, right? So 1 by 3 times I means it is simply 2 amps. So a 2 amps current that is flowing in this direction through the resistor. So 2 amps current is flowing in this direction due to the 28-volt battery. Now in the second step, right? In the second step, what I have to do is I have to just think about the whole part that has happened in between the points A and in point B, right? So here the current that is due to the 7-volt battery, how much it was? See here, the current due to the 7-volt battery was 2 amps downward, right? So that is what I have to write here. So it is 2 amps due to, right, due to 7-volt battery. And just now we made a calculation where it shows again 2 amps current is flowing through this resistor downward due to 28-volt battery, right? So one more current that I have to treat downward, it is also 2 amps, which is due to how much? 28-volt battery. When you add these two currents will give me when I add total current becomes 4 amps. Therefore, the potential difference and in same direction, right? Means for that one I added, right? So if they flow in opposite direction, I should make the subtraction. But here the two currents are flowing in same direction, right? Therefore, potential difference between the terminals A and B is VAB, which is nothing but the potential difference across R2, which is equals 4 amps multiplied by this resistor is of value 2. So definitely we get 8 volt, right? So 8 volt is our answer, and I hope you remember the same answer we obtained when we applied Kirchhoff voltage law, right? So in that also we got the same value, 8 ohm. So this is how we can easily solve such kind of network issues.